influence lines, Mueller-Breslau. What did we do last week?
Alternate.
We alternated the bays, right? Okay, so this is where that comes into play, is right here where it says partial loadings. Full intensity of the appropriately reduced live load applied only to a portion of a structure or member shall be accounted for if it produces a more unfavorable load effect than the same intensity applied over the full structure or member. And then it's got another sentence that says roof live loads shall be distributed as specified in table 4-1. Yeah, they are. These are. Yeah. I just released it at the base.
Oh.
All your connections are molded. Now, if you go over to table 4-1 and you look at roof live loads on page 18, all right, there's a superscript in, and if you go on the next page and look at this, the superscripts, it says where uniform roof live loads are reduced to less than 20 pounds per square foot in accordance with section 4.8.1 and are applied to the design of structural members arranged so as to create continuity, the reduced live load shall be applied to adjacent spans or to alternate spans, whichever produces the greatest unfavorable load effect. All right, so that right there also told me to look at pattern live loadings on the roof. Okay, so that's something I've got to think about. All right, so I'm just going to do one pattern live load just to show you, but let's start off with just L for live load, and then let's do L, and let's just do, we'll do B, or let's see, let's do this. Let's do L dash PAT. All right, so L pattern. Okay, L pattern, whatever it is. All right, and then I'm going to do pattern live load for my description. Okay, so I'm going to have, that's two different types of live loadings that I've got now. All right, and then let's do dead, store new, let's do SW, and I'll show you a trick on that, and we'll do self weight. And then let's just do wind. We'll skip snow. All right, so you should have 5 of them in there. You got wind, self-weight, dead, pattern live load, and live load. Okay? All right, so let's start off with dead load. Okay, where's the dead load applied to your structure? Over the top, everywhere, right? Okay, so you're gonna click on dead load, and then what I want to do is I want to do let's do a line load. Okay, I'm going to click on line load, and then it's going to bring up this dialog box, and I want to click on member distributed, and I want to click on generate load. Now, every time you do this, it's going to pop up right here and tell you what to do next. It says hit 2 joints to define the line. Okay, so I want to put my dead load from joint 13 to joint 16. And then this little dialog will pop up. Now, based on the coordinate system that I've got, which direction does my load go in?
Negative.
Negative what?
Negative.
Negative Y, right? Negative Y. This is for dead load. All right, so negative 0.2. Okay, and then I hit done, and it'll display the loading. And it says store load as generated. And I'm going to hit yes. Okay, then I'm going to click generate load again. And I'm going to click on joint 9 to joint 12 and do negative 0.2. Yes. Do the same thing again from 5 to 8. All right, so your structure should look like that. Everybody good on that? Smooth. All right.
If we have L equal 40 PSF, how do we get L equal 0.4 kip per foot?
Times 10 feet.
Time how much?
10 feet is my tributary width, which made it 400 pounds per foot, which is 0.4 kips per foot. Okay. Now, once you get these loadings, hit redraw at the top, and those will disappear. That they didn't, they're still there. Okay, you just can't see them. All right. Now, go back to independent active load and click on live load. And we're going to do a line load again. And you're going to do the exact same thing that you just did. All right, I'm going to go to 13 to 16. I'm going to do negative 0.4. I'm going to go from 9 to 12 and do negative 0.4. And then from 5 to 8 and do negative 0.4. All right. And then click redraw. So that's your dead load. What was it? Your dead load and live load is what I did. Okay. Now you have two options for doing the self weight of the members. Okay. You can treat them as self-weight and keep them separate, which can be easier sometimes to keep up with, or you can include them in the dead load. And I'm going to do them separately just to save a little bit of time here. Okay, so we're going to do self-weight. You're going to click on self-weight and see how right here it already has these options. Okay, self-weight of members, self-weight of elements. Okay, you're going to click on self-weight of members. And then you're going to tell it in which direction you want those loads to go, which needs to be in the negative y, which is the default. Okay, and you're going to hit generate loads. Yes. All right. So now it not only put the self weights of the members, but it also put the self weights of not only the beams but also the columns. Okay. So you got distributed loads along the beams, and you've got vertically distributed loads along the columns. All right, so that took into account your self-weight of your entire structure.
How did you do the entire structure again? Generate load and what?
I did what did I just do? I clicked on self-weight, and then you clicked on self-weight of members. You got it?
Yeah.
Okay. And I can't do it again. It won't let me do it twice.
So it applied on the columns too?
Huh?
It applied on everything.
It applied it to everything. Okay. Now you have the option of doing that yourself. Now you could go through and you could maybe have some crazy material that it doesn't have the unit weight in there. All right, and you got to go and do it yourself. But you would do that as a distributed load. Okay, but you'd have to go in and do it. All right. So then the last one we're going to do is wind. Now I'll do a pattern loading in a minute. But for the wind, you're going to click on, let's do member loads this time. All right, so click on wind and member. And now the dialog box will look a little bit different this time. But you're going to do force Y. You're going to click on force Y, and then the load distribution should be uniform. Now you have two options here. You'll get the hang of this as you go, but let's just do actual length on that right now. Yeah, I think it'll be easier. Yeah. All right.